Hello class, welcome to my first video, day 1 of Unit 7. We'll deal with vectors. I'm going to do my notes here. Hopefully my handwriting will be neat. If you remember vectors, you studied them in physics. Vectors are a little bit different than what we've maybe done in the past, but there's two things that maybe you studied before in physics. One is called scalars and one is called vectors. Scalars are just magnitude. They're just numbers. 40 miles per hour, 15 feet. They don't have a direction, where a vector is both magnitude and direction. A velocity, 40 miles per hour, southeast. A force of 10 newtons at a 40-degree angle. It's not just a number. I mean, there could be units, but a unit is not a direction. When you put a direction like southeast or 40 degrees and so on and so forth, that is making it a vector. We're going to deal with vectors for probably the first 3 lessons of this unit. Okay. Vector has a very special notation, and the notation looks like this. You use any letter you want for a vector. I was using the letter V, and on top of the letter V has this little, what I call an arrow hat on top of it. It's kind of like a half arrow. A little bit different than geometry class, where you had a ray that had like a full arrowhead on it. This is only a half arrow. Okay, I'm going to change colors. Okay, move it up a little bit. Okay, a line segment is something you did in geometry class. It didn't matter if you went from point P to point Q or from point Q to point P. These were the same line segment. A vector is different. Order does matter. It is a directed line segment. So when I say vector PQ, that means my initial side is P, my terminal side is Q, and this gives me vector PQ, where this other one is vector, is vector QP, because it starts at P and ends at Q. And if you pay attention, if you notice, they are not equal to each other. PQ, vector PQ and vector QP are not equal to each other. Okay, let me move this up a little bit. Now we're going to talk about what makes up a vector. Well, what makes up a vector are components. A vector has an x component and a y component. It has a horizontal component, it has a vertical component. So when we talk about a vector, we're talking about vector V as component v sub x and v sub y, which means it begins at the origin 0, 0, and it ends at the point x, y. As an example, vector v could equal 5, 3. Notice, these are not parentheses. These are pointy brackets. Whenever I use my pointy brackets, these are for vectors. That's what it means. I use parentheses for ordered pairs. I use pointy brackets for vectors. When I have a vector that is 5, 3, that means 5 is the x component and 3 is the y component. Not too bad. It's not too hard. Very similar to what you've done with ordered pairs, but just a little bit different. We're talking vectors because they have a magnitude and a direction. Okay, next page. So how can we get things into component form? Well, usually we could be given endpoints, x and y's endpoints for the points that we're dealing with, and we can find the difference between those values. Okay, order does matter when I do this stuff. So it is always the second point minus the first point. I deal with the x's together, I deal with the y's together. For my example, I have the order pairs -1, -3 for R and 5, 2 for point S. And when I wanted to figure out the v sub x and v sub y, I'm going to make this a little bit bigger. Well, v sub x is going to be, well, if it's RS, I have to do, the R is the first point and S is the second point. So I have to start with the S and do the x's first. So it's going to be 5 minus a -1, which is equal to 6. And my y is going to be 2 minus a -3, equal to 5. And my vector now is going to be the 6, 5 when I write it in component form. Okay. If you look on my diagram, RS with the 2 points on the graph, and I draw the vector from R to S, and when I'm done, I got vector V, and if you notice, vector V is equal to the vector RS. They have the same magnitude and direction. Even though they don't start at the same point, vector RS starts at the point -1, -3, and vector V starts at the origin 0, 0. But they do have the same magnitude, or what we call length, and they are pointing the same direction. How about vector SR? Well, vector SR would be equal to -6, -5. Clear that up a little bit. -6, -5, because it is the opposite of the original. V was 6, 5. SR is the opposite, -6, -5. Okay, let's scroll up. I'm going to try an example now. Of course, me using the stylus on here, I'm not going to be right as neat as I normally can. So you're going to have to bear with me a little bit. Okay, I'm going to draw the vector PQ using the points -3, 4, and 5, -2. I'm going to change it to black. So -3, 4, and then 5, -2, and I'm drawing it here to here. That's point P, that's point Q, and when I want to do the X, it's going to be Q minus P, or 5 minus a -3, which is 8, and V sub Y is going to be -2 minus 4, which is -6, and I get vector B, which is going to be the new vector PQ, is equal to 8, -6. And I'm going to do that in a different color. So for this one, I start at the origin. I go to 8, -6, and if I do this right, there is my vector V, or my vector PQ. Little squiggly, but you notice that they really are the same length, same magnitude, and are pointing in the same direction. So what would QP be equal to, change my color. QP would be the opposite. It would be -8, 6. Again, it starts at the origin and goes to -8, +6. And if you notice, there is QP, vector QP. Equal in magnitude, but going the opposite direction as before. Okay. Same magnitude, but opposite direction. Okay, let's see. So let's talk about how we come up with our magnitude and direction for everything. Well, another name for magnitude is length, or what we call distance. And it's just from the beginning to the end. I'm going to use the distance formula. If you remember, the distance formula from geometry class is based on the Pythagorean theorem, which according to what I have here, this is my A side, and this is my B side, and this is my hypotenuse. That would be Vx squared plus Vy squared is equal to side V squared. And again, we use a little bit special notation. When we put absolute value bars around the vector, that means it's magnitude. It's absolute value or magnitude. Now, when I want to do directional angle, I'll call this 1. I'll call direction 2. Call that 2. Well, let's think about trigonometry. Well, when we were in trig, we know tangent of theta was opposite over adjacent, and that's the y side over the x side. So here are my two formulas. Here's my magnitude formula, and here is my angle formula. My direction is my angle. I'm going to use everything in degrees. I'm going to use my calculator. Again, it's not too hard, but you got to be careful. Here's a hard part right here. Remember, when I do inverse tangent, I may not get the quadrant that I want. Inverse tangent can only give a quadrant 1 and quadrant 4 angle. So if it doesn't match, I got to add 180 degrees. Okay, let's try an example. I'm gonna make this bigger so I can, when I write, you guys can see better. Okay. The magnitude of my example here, 6,5, is going to be the square root of 6 squared plus 5 squared, which is equal to the square root of 61, which is about 7.81. Okay? The vector 6, 5 is in quadrant 1. So when I want to do my angle, I'm going to do inverse tangent of the y over the x. I get 39.8 degrees, which is also in quadrant 1, which checks out. The vector 6, 5 is in quadrant 1. My inverse tangent is an angle in quadrant 1. I am good. So what would be the magnitude and direction for SR? Well, the magnitude for SR is going to be the same. Square root of 61. That hasn't changed. But my angle which was 39.8 degrees, is no good. What do I need to do? Well, -6, -5 is in quadrant 3. I got to add 180 degrees to that. So I get theta is equal to 219.8 degrees, if that makes sense. Okay. Next page. Now at this point in the video, I have two examples here that you should work on yourself. If you want, you can pause the video and work on it yourself and then come back to it, because I'm going to go through this pretty quickly. I might not talk too much, but at this point you should work on problem number 2 and problem number 3 and check your results when you're finished. Okay, as you can see, I've done all the work for problem number 2. I drew PQ on the grid. I did the x and y component, and I got my new vector r as 6, -8. And I drew that vector from the origin, and you can see it is the same length and direction. And then I did the magnitude, which I got to be 10. And I got the theta to be -53.1 degrees, which is in quadrant 4, and vector r is in quadrant 4, so they match. But I didn't really like it that so much. So I decided to stay between 0 and 360, and I added 360. You can always add or subtract 360 to any angle that you want, because it gives you an angle in the same location as before. So instead of calling -53.1 degrees, I called it positive 306.9 degrees. Okay, please check your results. Pause the video if you want. I'm going to move on to question number 3. Okay, as you can see, I did problem number 3, and if you look at it, I did draw my original TU vector. I rewrote it as vector v by doing the components. I got -7,4 as the components, and if you look at it, it's like the same magnitude and direction as before. I figured out the magnitude and direction. The magnitude is just the x component squared plus the y component squared. Then I take the square root of it. Square root of 65, or a little bit more than 8. When I did the angle, I got -29.7 degrees. Well, -7,4 is in quadrant 2, but -29.7 degrees is in quadrant 4. That's not the same. Therefore, I have to add 180 degrees, and my theta, my directional angle theta, is 150.3 degrees, which is in quadrant 2, and that does match up. Okay, this last page will be a little bit easier. First, we're going to deal with a scalar multiplication. A scalar is just a number. So we're going to multiply a magnitude, or a vector, by a magnitude k, just some number. So it's basically just like doing the derivative property to the x and y component. As an example, 2 times the vector 6, 5 becomes the vector 12, 10. What can we say about a magnitude and direction? Well, it is the magnitude is equal to double, and it is the same direction. Well, what happens if I do -1/2 of 6, 5? Well, I get the answer of -3, -2.5 as my new vector. What do you think the magnitude is now? Well, the magnitude is equal to half, and the direction is the opposite direction because of that negative sign. It made everything opposite. So next what we're going to do is work on vector addition. Vector addition is really, really easy. All it is adding the x components together and the y components together. That's all it is. Sometimes it's called the parallelogram law or the triangle law, because if you think about it, if you have vector u down here and vector v over here, well, what you could do is you could redraw vector v over here, or u on top here, And what you can do is complete the parallelogram, and that is the sum of u plus v, or what I call doing tip to tail addition. Okay, let's go through an example. Vector v plus vector w. Well, vector v is 4, 3, plus vector w, which is -2, 1. And I'm going to add them together. And when I do this, all I'm doing is saying my results. Vector r, add the x's together, I get 2. Add the y's together, I get 4. I get the new vector 2, 4. Well, that's what I did over here. 2, 4. Here's my v, which was 4, 3. And here's my w, which was -2, 1. And I add them together, I got 2, 4. Not too hard, pretty easy to do. How about subtracting vectors? Well, I don't really like to subtract vectors because they have components to it. I really just add opposites. Well, think back in arithmetic. 5 minus 2 is really the same as 5 plus a -2. And that's exactly the way I'm going to handle vectors. Instead of subtracting one vector from another, I'm going to take one vector and add the opposite to it. So as an example, well, we'll get to that in number 5. We'll do number 4. We're going to have some scalar stuff going on here. I'm going to give myself some room. So 2v is equal to 8, 6 plus 3w, which is equal to -3, 6. And when I'm done, my result is 5, 12. That is the components of my result. If I want the magnitude of this, 5 squared plus 12 squared. I put that in the calculator, and my magnitude is 13. If I want to do my angle, I do inverse tangent of 12 over 5, and I get 67.4 degrees, and that's in quadrant 1, and my original result was also in quadrant 1, so that checks out. So 2v plus 3w is 5, 12 with a magnitude of 13 and a directional angle of 67.4 degrees. Okay, problem number 5 does deal with subtraction. So I'm going to do 3v, which is equal to 12, 9. And I'm going to do -2w, which is equal to 2, -4. And what I'm going to do here, I'm going to add them together. So instead of subtracting them, I just did -2 times w. I get a final result equal to 14, 5. So the component of my new vector is, or my resulting vector is 14, 5. When I want to do the magnitude, which is going to be 14 squared plus 5 squared. So my result, the magnitude of my r is the square root of 221, which is about 14.9. And when I want to do my theta, I'm going to do inverse tangent of 5 over 14. I get my theta is equal to 19.7 degrees. And if I pay attention to this, well, my original 14.5 is in Q1, and my theta is also in Q1, and it checks out. Okay, I will have all the notes posted online on my portal if you want to look at them page by page, but this is me going through the portals. I hope it went well. Please rewind or stop the video anytime and rewatch it. Thank you.